I will come back to our last example, example 3 and 2.1, functions and equivalent algebraic expressions. It says we're given a square of side length 7 that is removed from a square of side length x. So here's our square of side length x, and we've removed from it another little square with side length 7. Express the area of the shaded region as a function of x. So we want to get an expression for this shaded region in here. So there's a quick, easy way to do that. So the area of the shaded region is just going to be the large area minus the small area. So large area is going to be x by x, so that's x squared. And the small region is this 7 by 7 square, so that's 7 squared. So we're left with x squared minus 49. All right, that's easy. Part B, write the area function in factored form. We got a nice perfect square here, perfect square here. We call this difference of squares, right? So it's going to be, we square root the first number, the first term, we get x. Square root the last one, we get 7, so it's x plus 7, x minus 7. Okay, part C. Use both forms of the function to calculate the area for x values of 8, 9, 10, 11, and 12. So I'm just going to do a couple of these, and then we'll go ahead and see which one is easier to use. So I think we can do this way. We'll say when x equals 8 centimeters, so we'll go ahead and we'll calculate the shaded area using this one first. 8 squared minus 49, that's going to be equal to 64 minus 49, which is going to be 11 and 4, 15. Okay, and then on this side, I'll use this one. So we'll have 8 plus 7 times 8 minus 7. So that's 15 times 1, which is just 15. Okay, those are going to be centimeters squared, both of those. Okay. I kind of like the factored form a little bit better. Quick, easy math. Let's see, we'll go with 9 centimeters next. So we'll have 9 squared minus 49. That's going to be 81 minus 49, which is going to be 32. And then using the other method, we would have, we're plugging 9 into here, right? Into x. So we have 9 plus 7 times 9 minus 7. So this is 16 times 2, 32 centimeters squared. So I feel like this is definitely easier, the factored form. So both these expressions are equivalent. You can tell what they're trying to get at with this example. However, I do like doing calculations in this one here. They are a bit easier. All right, moving on to D. What is the domain of the area function? Okay, so since this function represents an area, we should restrict it. So we'll say it must be restricted to x values that do not result in negative area, in negative or zero area. Okay, so we got to keep the area positive, obviously, for this. So there's restrictions on the domain. There's restrictions on the size of x in order that this shaded region stays above 0. So I can see here the best way to figure this out is in order for the area to stay positive, if I look at this term here, if x is 7, I'm going to have 49 minus 49, I get 0 area. So I want this x to be greater than 0. So we can say here, so therefore the domain, we can say x is an element of R, and we'll just say x greater than 7. Okay, that way our area will always stay at least positive. You can also tell that from this expression too. When x is greater than 7, this is positive and this one is positive. This one will be small, but they're both positive and you'll get a positive area. All right, that's it for this lesson. I will see you guys next time.